Homework busy? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
Hi, everybody. So this is basically saying, is the use of non-relativistic formula justified in the Bohr's atom? And here we have the Bohr's quantum condition. And if I can make quantum look nice for everybody, quantum condition. There we go. And that's going to be your mass times velocity times the radius, we have n, equals the n, or your energy state, divided by 2 pi. 2 pi. There we go. And so we need the grand state, and we're going to get the V over. So if we're going to do the V over, for your velocity, you have h, your Planck's constant. Actually, I just skipped the state. So you want to add the first or the grand state. So your grand state is going to be 1. So here we go. Let me go 1. There we go. Now I'm not skipping. It doesn't matter if you put everything over. So if we do this here, we got M, V, R, and this is going to be to the 1. And then we have 1 here, Planck's constant times 2 pi. And we're going to do this. Okay, and we can do the V over. And you can do that ahead of time too, which was I was about to do. But we can just do it this way. So 2 pi R1M. Okay. And now we're going to plug in all the information. So we have Planck's constant, which is 6.63 times 10 to negative 34 joules per second. And this is 2 pi times the radius here, which is going to be 9.1. The Bohr's constant can be 9.11 times 10 to negative 31 kilogram. Okay, and that's the proton here. Times the mass of it is going to be 0.529 of proton times 10, negative 10 meters. Okay, and I'm going to bring this down a little bit. And if we plug this entire thing into your calculator, you're going to get 2.19 times 10 to the 6 meters per second. And now we want to take the C out, and you'll see just why. So we're going to divide this by your C. And when we do that, the speed of light, we're going to get 7.3 times 10 to negative 3 C. And your C is going to be 3 times 10 to the 8 meters per second. Okay, so that's your C, if you're curious. If you haven't memorized that yet. So we're still not done, because they gave us a formula, the relativistic factor formula. Okay, and that is given to us as 1 minus V divided by C. And we have squared, okay? So from this, we already have your V, and here we have, it looks like we still have 1 minus, there we go, 1 minus your V over C. Oops, and it looks like, because what we're doing is dividing it by 2. So we have 1 for each one, because the square root of 1 is just going to be 1. So here we end up with your VC, so 7.3 times 10 to the negative third. And from this, we end up getting about 0.99635. Okay. And my 3 looks really terrible, so let me just fix that for everybody. There we go. And this is going to be, it's essentially 1. So the use of non-relative formula is justified. So I'll write close to 1. So the use of the non-relativistic, and I'm going to write that next line over. So non-relativistic formula, and let me just spell formula wrong. Formula, there we go. Formula is justified, okay, guys? And this is just math if you're curious, okay, guys? Thank you so much, and hope this helps.